This is Jacob's Algebra, Chapter 12, Lesson 2. This lesson is on square roots of products. So we learned before that square roots, if you have square root of x, we can write that as x to the 1/2 power. Make sure that you remember your order of operations rules, PEMDAS. Remember parentheses, exponents, multiplication, division, and addition, subtraction. If you have 3x to the 1/2 and you're going to write that as in radical form, this 1/2 only applies to the x because exponents come before multiplication. So this would be 3 square root x. If you have the square root of 3x, then you cannot just write that as 3x to the 1/2 because that would mean 3 times the square root of x. If you want to write the square root of 3x in exponential form, you have to put this in parentheses to show that the 1/2 power applies to everything. So be careful with your order of operations. 3x to the 1/2 is 3 times the square root of x. 3x in parentheses to the 1/2 is the square root of 3x. These are very different things. Now, you may remember when we were covering exponent rules, if we had x times y to the nth power, that was the same as x to the nth times y to the nth. Well, this means that if you have x times y to the 1/2 power, which remember is a square root, that's the same as x to the 1/2 times y to the 1/2. So the square root of xy is equal to the square root of x times the square root of y. What this means is that we can simplify our radicals. So let me show you a couple of these. If we have something like the square root of 200, what you need to do is look at this number and see what is the biggest square factor of 200 that I can come up with. Well, when I look at that, I see 200 as 100 times 2. 100 is a square number. So this is the same as the square root of 100 times the square root of 2. Well, I know what the square root of 100 is. The square root of 100 is 10. And then I still have a 2 left in the square root. You do not have to do this intermediate step of writing out the square roots separately. You can go straight from square root of 100 times 2 to 10 square root 2. The things that you have to be very careful of are that when you take something out of your square root, you have to remember to square root it. And then also, once you have taken something out of the square root, you have to remember to not put it back in the square root. The square root of the quantity 100 times 2, we take that 100 out. When we do that, we have to change it to a 10 because 10 is the square root of 100. And then the 2 is left behind in the square root. Another one we might look at is 125x cubed. So I'm going to look at the number. What can I break that up into? What are the factors of 125? It will be very helpful to use a list of squares like I recommended during class. Remember that back on page 563 in your book is a table of squares and square roots. I recommend that you photocopy that page and have it sitting in front of you to look at so you can just glance down and see, oh yes, this is the square. This square is a factor of 125 because it'll be much easier for you to work these problems if you do that. I know that all of you did mark that page with tabs during class, so at least you can easily refer to that page. Now, when I look at 125, the biggest square factor in that, in fact, the only square factor in 125 is 25. So I'm going to write 125 as 25 times 5. Now I'm going to look at my x cubed. What is my biggest square factor in x cubed? Well, that would be x squared. But then I still have an x left over. So what I'm going to do now is pull out my two squares. When I pull out the 25, it becomes a 5. When I pull out the x squared, it becomes an x. That's because the square root of 25 is 5 and the square root of x squared is x. And then what's left behind in the square root are my 5 and my x. So, oh, sorry, I did not mean to put an equal sign in here. That goes away. And this needs to be moved over. Okay. So what remains behind in the square root is 5x. So 125x cubed, when we square root the whole thing, becomes 5x times the square root of 5x. Okay, so let's do a couple of the sample problems. Number 4 says, write each of the following in radical form. This is for the first several parts of number 4. So it's going to give you exponential form, and you need to write it in radical form. So we're first going to look at part B, which is 6x to the 1/2. Remember, the 1/2 is our square root. What are we square rooting? The entire thing, because the entire thing is in parentheses. So this is the square root of 6x. Now we look at part C, which is 6x to the 1/2. Remember, exponents come before multiplication, so the 1/2 power applies only to the x. So this is 6 times the square root of x. Notice how different these look. Pay attention to this. Okay, next we're going to do part D, which is x cubed to the 1/2. And that, the entire thing is inside of a square root, so we write square root of x cubed. Now, for number 4, for the first problem in set 3, number 4 is just like number 11. You do not have to simplify for this one. For all the other problems, you have to simplify. For the first problem in set 3, you do not have to simplify. You just have to write it as it is. Just change it from exponential form to radical form, or from radical form to exponential form. But if you do go ahead and simplify your answer, that won't make your answer incorrect. So simplifying is okay here. It's just that this is the only problem where you don't have to simplify. Okay, let's look at part F. Part F is 3xy to the 1/2. Again, this 1/2 applies only to the y. So this is 3x times the square root of y. Exponents are stronger than multiplication, so the exponent applies only to the y. The next one is G, 3 times xy to the 1/2. Okay, parentheses are stronger than the exponent, so we have 3 times the square root of xy. So remember your order of operations, PEMDAS. It's parentheses, exponents, then multiplication, division, then addition, subtraction. Okay, so now we're going to look at the other part of number 4. The second half of number 4 says write each of the following in exponential form. So here you're going to be given the radical form, and you need to convert it to exponential form. So part I says 5 times the square root of x. Okay, well, we'll write down our 5. And our square root applies only to the x, so we can just write x to the 1/2. Let's look at part J, which is, the square root of 5x. Okay, in this case, the half power applies to everything, so we have to put the 5x in parentheses and then raise it to the half power. Skip over to part M. Part M says x times the square root of 7y. Everything that the half power applies to needs to be in parentheses. So this is x times 7y to the 1/2. And then part N is 10x square root y. Since the square root only has to apply to one thing, we can just write 10xy to the 1/2, and that 1/2 will apply only to the y. Okay, so that was number 4, which is just like number 11 that I assigned for homework. Let's look now at number 5. Number 5 says, what number should replace the blank in each of the following equations to make it true? So let's look at part A. We have the square root of 9 times 11, and that equals something times square root 11. What needs to go here? Well, if we look back at what we started with, we have a 9 times 11 under the square root, and we end up with just an 11. That means that the 9 came out. When we take the 9 out of the square root, we have to square root it. The square root of 9 is 3. So this is going to be 3 square root 11. Let's jump down to part C. Part C is the square root of 16 times 36. And this just says equals blank. Well, if you look at this, remember with products, you can take the square root of each part separately. The square root of 16 is 4. The square root of 36 is 9. What is 4 times 9? It's 36. Okay, let's jump down to part E. Part E is the square root of 2 times 2 times 13, and it equals something times the square root of 13. Well, the 13 we can see is on both sides. What we don't have in our square root anymore is this 2 times 2. Well, 2 times 2 is 2 squared. When we pull that out of the square root, we have to square root it. The square root of 2 squared is 2. So this is going to be 2 square root 13. Okay, let's jump down to part G. Part G is the square root of 4 times 15 times 100. And that is equal to something times the square root of 15. Okay, so 15 is the only thing that's left inside of the square root. The 4 and the 100 are no longer in the square root. When we pull the 4 out of the square root, we have to square root it. That makes a 2. When we pull the 100 out of the square root, that becomes a 10 because the square root of 100 is 10. So this must be 2 times 10, and 2 times 10 is 20. So our answer is 20 square root 15. And then we'll do one more part. Let's look at part H. Part H is the square root of 3 times 3 times 3 times 31. And that is equal to 3 times the square root of something. Okay, in this case, we know that we pulled out a 3. To get the 3 on the outside, that means we had to get rid of 2 3's on the inside because it's 3 squared. So this 3 right here is these 2 3's right here. So what is left under the square root is the 31 and one more 3. So what's underneath the square root is 3 times 31, which is 93. So 3 square root 93 is our answer. Okay, so that was number 5, which is just like number 12 that I assigned for homework. Next, we're going to look at number 6. Number 6 says write each of the following in simple radical form. This means you must simplify your radical. If there is a square number inside of your radical, you have to take it out. So let's look at part A. Part A is the square root of 12. Okay, there's a lot of different ways to factor 12, but you want to find a square factor of 12. The only square factor of 12 is 4. So I'm going to break 12 up into 4 times 3. I can take the 4 out of the square root. The square root of 4 is 2. I still have the 3 left behind in my square root, so this is 2 square root 3. Let's look at part C. Part C is square root of 32. Now we have 2 different ways we can work this, so I'm going to show you both ways. You might see immediately that 4 is a factor of 32, and 4 is a square number. So you'll say this is the square root of 4 times 8. 4 is my square number. When I take the square root of 4, I get 2. So I have 2 times the square root of 8. But 8 has a square factor also. 8 can be factored into 4 times 2. So I need to take this 4 out of the square root. When I take the 4 out, it's going to become a 2. So 2 times 2 is 4, and I have 4 times the square root of 2. If you happen to keep your list of handy square numbers next to you, you might notice instead that 32 also has 16 as a factor. So you can take 32 and write it as 16 times 2. Okay, the square root of 16 is 4, and then we just have a 2 left behind. You can see it's a much shorter problem if we use the bigger square number. So just letting you know, if you happen to be looking at the numbers and you get through and you get something like 2 square root 8, make sure that you check what you still have left under the square root and see if it has a square number as a factor, because it might still have a square number as a factor. And we will continue on with this in the part 2 video. This was number 6, which is just like number 13 that I assigned for homework.